ended up with this fraction here, and that was from a function given to you, and we'd like to simplify this. And it turns out there's a couple things wrong here, and that one of them is it's a compound fraction, and also you got a radical in the denominator. And so we'll take care of that. Now notice right here we've got the absolute value, and we can simplify that because everything inside here, the 2 over square root of 13, it's always going to be positive, so this is really unnecessary. We can just assume that it's removed. And so this is perfectly acceptable and equivalent. And we have a fraction in a denominator here that we can sort out. And one way, the most straightforward way to get rid of this, or at least to simplify this sum, is to combine it with this 1. And in order to add 1 or subtract 1, or in this case subtract this ratio from 1, we need to make sure the denominator is the same. And we have a square root of 13 in the denominator here. We'll need to do that over here. And so we can equivalently make something that has a square root of 13 in the denominator that still is a ratio of 1. Like square root of 13 over square root of 13. That divides to 1. It's equivalent. Now we have a common denominator in the bottom, so we could actually combine these two. Where on the top we have square root of 13 minus 2, and in the denominator we have square root of 13. And that's what we have here. And we can even simplify this because this all is in a denominator. We can actually bring this square root of 13 up to the numerator like this. And so this is what we finally end up at. Now you're probably wondering, well, what do we do? Here there's supposed to be 9 there. I tell you, the trick is that the 9 is a side effect of a cool trick here. And that is, well, the Pearson math labs don't like radicals in the denominator. They like you to reformulate these where you don't have a radical in the denominator, which means you have to multiply the denominator by something to make the radicals disappear. Well, this is a square root. And so like, hey, what if you were to multiply the top and the bottom by the same amount to make the square roots disappear? And this is a tricky one here. That's sort of a thing that I'll have to show you before you really grasp it. And that is, you multiply it by 1, which is this square root of 13 plus 2. Notice that it's the same in the top as it is in the denominator, so it divides to 1. But when we multiply them, we get, for our first term, square root of 13 times square root of 13, which is equal to 13. And then the middle one is negative 2 times square root of 13. Then you get a positive 2 times square root of 13. And then you've got a negative 4. That's just basically doing the FOIL, the first, inner, outer, and last in the denominator. In a numerator, you do square root of 13 times square root of 13, which is equal to 13. And then you've got 13 times square root of 13 times 2. So this is what we end up with. We've got these simplified here in a numerator. No longer a square root, but we have a square root here, though. But then here's the interesting thing. Those two square root of 13s multiplied to become 13. And now the inner and the outers, we got a positive 2 times and a negative 2 times. These, being the same but opposite, they add up to 0. They disappear, leaving you only with a 13 minus 4 in a denominator. And you subtract 4 from 13, you end up with 9. And this is more acceptable because there is no square root in the denominator.